Bismillahirrahmanirrahim. Assalamu alaikum. I hope that you all are having a good time at your homes. This is week 4 and day 2 of class 9th physics, and today we are going to solve the numerical problems of unit number 5 named as gravitation. Now let's reinforce our previous knowledge. As we know that in unit number 5 we have discussed few formulas. First one was the Newton's law of gravitation. Second one was of mass of the earth. Third one was in variation of g with altitude, and the fourth one was of the motion of artificial satellites. So we will use these four formulas and solve all the numerical problems of unit number 5. So let's get started. The first problem we have on page number 115 of your textbook is find the gravitational force of attraction between the two spheres, each of mass 1000 kg. The distance between the centers of the spheres is 0.5 meter. There are two masses named as m1 and m2. Both have the same mass which is 1000 kg, and the distance between them is 0.5 meter. As we know that Newton's law of gravitation, we can find out the gravitational force, which is F. The formula is F is equals to gm1 m2 divided by d square, where g is the universal constant of gravitation and its value is here. So by using this formula, we will put the values of g, m1, m2 and d from this data. The equation will be like this. Now we can also write 1000 as a 10 power 3. Why? Because as you can see here, the number of zeros along with 1 can be written in the power of 10. Let's say there were 4 zeros with 1. It means that it was 10,000. So we could also write it as 10 raised to the power 4. Same with this case, we have 3 zeros with 1. We can write it as 10 raised to the power 3. And same for this. Now, both have the same bases and they are multiplying. So if the numbers have the same bases and they are multiplying, we can simply add the powers and write the base as ones. Let's say this is the 10 raised to the power 3 and this is also 10 raised to the power 3 and they are multiplying. We can simply write it as 10 raised to the power 3 plus 3, which will be equals to 6. Same for this case. 10 raised to the power 11 multiplied by 10 raised to the power 6. It will be written, the base will be written once, which is 10, and the powers will be added. Minus 11 and plus 6. Minus 11 plus 6 is equals to minus 5. Now if you divide 6.673 divided by 0.25, you will get the answer as 26.69. Now we want to shift the point towards the first non-zero digit. What will I do? If we want to move the point towards left, you'll get the 10 raised to the power positive. But if you want to move the point towards right, you'll use the number as 10 raised to the power in the negative. So here you can see it's 26.69 and you want to move the point towards the left. So we will simply write it as 10 raised to the power plus 1. And as we are moving the point 1 digit, and that's why we are writing it as 10 raised to the power plus 1 multiplied by 10 raised to the power minus 5, which was written before. Now same with this case, bases of both numbers is same, 10 raised to the power plus 1 and 10 raised to the power minus 5. So we can write the base 1 and add the powers. Plus 1 minus 5 will be equals to 10 raised to the power minus 4 Newton. So the answer will be 2.67 multiplied by 10 raised to the power minus 4 Newton. This is your first statement's answer. Second one, the gravitational force between two identical lead spheres, identical means same, kept at 1 meter apart is 0.006673 Newton. Find their masses. They said we have the same masses, we have same lead spheres, we don't know their masses, and the distance between their centers is 1 meter. and the force of gravitation is 0.006673 Newton. So same, just like 5.1, we will use the formula of Newton's law of gravitation, but here we have to find out the mass, not the gravitational force. And the masses are same. So I'll just, as since both the letters are identical, so I can write it as m1 is equals to m2, and it can simply equals to m. So I can replace m1 and m2 as m. So m multiplied by m will be equals to m square. And now, as you know, I want to find out the masses. So I'll shift d square and capital G towards the left hand side. So the equation will be m square is equals to fd square divided by capital G. By putting the value of f, d and g from the given data, we will get the answer as here. Now, as you can see, the point is here. I want to move the point towards the first non-zero digit. So I can write it as 6.673 multiplied by 10 raised to the power minus 3. Yes, because I am moving the point towards the right hand side. So the power will be in negative. The square of 1 will be equals to 1 and divided by 6.673 multiplied by 10 raised to the power minus 11. Now we can simply, if you move the 10 raised to the power minus 11 towards the numerator, the power will be positive. The sign of the power change. As you can see, in denominator it was negative. If you move it towards the numerator, it will be positive. So 10 raised to the power minus 3 and 10 raised to the power minus 11 will be 10 raised to the power plus 11. And you can simply cancel 6.673 to 6.673. By solving this, as they both are having the same bases, we can write the base once and adding the power. It will be 11 minus 3, which will be equal to 10 raised to the power 8. Now we had the mass as square. So to remove the square, we will take the square root. It will be m is equal to 10 raised to the power 4 kg. It means 10 raised to the power can be written as 10,000. 1 with 4 zeros. So both masses were same, so same value for m1 and m2. So the masses m1 and m2 is equals to 10,000 kg. Let's move on to numerical number 5.3, which is find the acceleration due to gravity on the surface of Mars. The mass of Mars is 6.42 multiplied by 10 raised to the power 23 kg and its radius is 3370 kilometer. So we have to find out the gravitational acceleration, which is g, and because it is on the surface of Mars, so that's why I write m in the subscript. And the mass of Mars is written as 6.642 into 10 raised to the power 23 kg, and the radius is 3370 kilometer. As you know, the prefix of kilo is 10 raised to the power 3 or 1000, and here there is no point. So I'll simply just write it as 0.0 and move the point towards the first non-zero digit. So it will be 3.37 multiplied by 10 raised to the power 3. Because I am moving the point towards the first non-zero digit and I have covered 3 numbers. So it will be 10 raised to the power 3. And for kilo, I will write it as 10 raised to the power 3. So bases are same. Same, we will get the answer 3.37 multiplied by 10 raised to the power 6 meter. The value of G is 6.673 multiplied by 10 raised to the power minus 11 Newton meter square per kg square. As we have discussed this formula and mass of the earth, that Gm is equals to capital G m divided by r square. So I'll use this formula and putting the values in from the given data in this formula. You can write it as here like this. So firstly, what will I do? I will take the square of this. This will be the answer. Then I'll multiply 6.673 into 6.42. You'll get it as 42.84. Now same in this equation, I'll move the 10 raised to the power 12 towards the numerator because the power was in positive. So when it will move in towards the numerator, it will be negative. So bases of these three numbers are same and they are multiplying, so I can simply write the base once and add the powers. It will be 23 minus 12 minus 11. So 42 divided by 11.37 and minus 12 minus 11 is equals to minus 23, or 23 minus 23 is equals to 0. If you see here, it's 10 raised to the power 0. The number whose power is 0, the answer will be equals to 1. Either it's 5 raised to the power 0 or 10 raised to the power 0, the answer will be equals to 1. So here you can see it's 10 raised to the power 0, we will write it as 1. So 42.84 divided by 11.357 will be equals to 3.77 meter per second square. Why did I write as meter per second square? Because the unit of gravitational acceleration is meter per second square. 5.4. The acceleration of due to gravity is mentioned, which is 1.62 meter per second square. So it is on the surface of the moon. The radius is 1740 kilometer, and we have to find out the mass of the moon. As the radius is 1740 kilometer and the prefix of kilo is 1000, so I'll write it as 10 raised to the power 3. And here, if I shift the point towards the first non-zero digit, it will be 1.74, and I have moved the digit towards the first non-zero number by covering 3 numbers, so I'll write it as 1.74 multiplied by 10 raised to the power 3. Bases are same for this case, 10 raised to the power 6. 3 plus 3, I'll write the base once. And we have to find out the mass of the moon. Now, in mass of the earth, we discussed the formula as Gm is equals to capital Gm divided by r square. So if I want to find out the mass of the moon, I'll just move the r radius, g universal constant of gravitation, towards the left hand side, and it will be equals to mm is equals to Gm r square divided by capital G. By putting the values from the given data, you can simply write it the equation like this. By taking the square, it will be like 3.02 multiplied by 10 raised to the power 12. Now multiplying 3.02 to 1.62, it will be 4.90. And if I shift the value in the denominator, that is 10 raised to the power 11 minus 11, towards the numerator, it will be 10 raised to the power plus 11. Now bases are same, powers will be added, 10 raised to the power 23. 4.90 divided by 6.673 will be 0.735. So what would I do? I would simply shift the point towards the first non-zero digit. So as I am moving the point towards the right hand side, the power will be negative. So I am moving the point one number towards the right hand side, so it will be 10 raised to the power minus 1. And bases are same, so it will be the 10 raised to the power minus 1 plus 23 will be equals to 10 raised to the power 22. So the mass of the moon will be 7.35 multiplied by 10 raised to the power 22 kg. Last numerical for today is 5.5, and it is calculate the value of G. Same. As you remember, we have used just two formulas. First one was Newton's law of gravitation, and second one was the mass of the earth. So in this, because they are asking about height, I'll use the third formula. Calculate the value of G at the height of 3600 kilometer above the surface of the earth. So height is 3600 kilometer. For kilo, I'll write it as 1000 or 10 raised to the power 3. And I shift the point towards the first non-zero digit. As I'm moving the point 3 digits towards first non-zero digit, it will be 3.6 multiplied by 10 raised to the power 3. And 1000 can be written as 10 raised to the power 3. So the bases are same. We can write the base at once, and it will be 3 plus 3, which will be equals to 6. So height is 3.6 multiplied by 10 raised to the power 6 meter. As we know, the mass of the Earth is equal to 6.0 multiplied by 10 raised to the power 24 kg. And we have to find out the g at some height. That's why I write h in the subscript. And we know that radius on the surface of the Earth, is 6.4 multiplied by 10 raised to the power 6 meter. So for this, we have discussed this formula in variation of g with altitude, and the formula was gh is equals to gme divided by r plus h square. I'll write the value of g as 6.673 multiplied by 10 raised to the power minus 11. Mass of the Earth is mentioned here, r is mentioned here, and h is mentioned here. So I'll put these values in this equation. Now next thing, what will I do? I'll simply, when you are adding the equations, when you are adding the numbers, the powers of 10 will not be added. It would be written once. Let's say it is 10 raised to the power 6 plus 10 raised to the power 6. It will be equals to 10 raised to the power 6. Let's say I am having an example of 4 bananas plus 3 bananas. So bananas are 10 raised to the power 6. So the answer will be 7 bananas. I'm not saying it as 7 banana square. Clear? So here, as if you can see here, it's 6.4 multiplied by 10 raised to the power 6 plus 3.6 multiplied by 10 raised to the power 6 will be equals to 10.0, and 10 raised to the power 6 will be written as ones. Clear? Let's say we have an example of apples. 4 apples plus 2 apples will be written as 6 apples. It cannot be written as 6 apples square. Clear? So if we are adding the 10 raised to the power 6, the power will be written once. Now, as here I am multiplying this, so for this 6.673 multiplied by 6.0 will be equals to 40.038, and 10 raised to the power minus 11 multiplying by 10 raised to the power 24. Because I am multiplying here, so both have the same bases, so I'll write the base once and add the powers minus 11 plus 24. It will be plus 13. By taking the square of this value, 10 square will be equals to 100, and square of 6 will be equals to 12. Now square of 10 raised to the power 6 square 2 means 6 multiplied by 2. It will be 10 raised to the power 12. Now we can write 100 as 10 raised to the power 2 because there are 2 zeros along with 1. So the power of 10 will be 2. Both have same bases. You can write it as 10 raised to the power 14. Now, if I shift this power towards the numerator, it will be 10 raised to the power minus 14 because the sign will change. Same, both have same base. I'll write the base once and add the powers. 13 minus 14 will be equal to 10 raised to the power minus 11. Now, it's 40.0. 40.0, for this I'll move the point towards the left hand side. So if I'm shifting the point one digit towards the left hand side, we can write the 10 raised to the power as positive 1. Now 10 raised to the power plus 1 minus 10 into 10 raised to the power minus 1. Both have same bases and the powers will be added. It will be 10 raised to the power 1 minus 1, which will be 10 raised to the power 0. And we know that the power of any number, if the power of any number is 0, then the answer will be 1. So 10 raised to the power 0 will be equals to 1. 1 multiplied by 4.0 will be equals to 4.0. And as the unit of g is 4 meter per second square, so the value of g at a height of 3600 kilometer above the surface of the Earth will be 4.0 meter per second square. Now your assignment is to do the written practice of these numerical problems, and if you have any question you can comment down below and ask me. That's all for today. Hope you are having a great time, and Allah Hafiz.